So today I'd like to play around with three ideas. So we're going to play around with static variables, and we're going to explore static methods and Boolean methods. So essentially with static variables, I mean, these are variables that don't change. They're independent of objects. We're going to sort of elaborate on that later. And of course, similar to static variables, we also have static methods in that they don't change they don't change object to object as well. And Boolean methods, we're going to play with Boolean methods because we haven't really worked with returning a Boolean value in the method and actually relaying that back to our main program. So these Boolean methods, they're either going to return true or false, and we're going to reference whether or not it's true or whether or not it's false, and actually execute different actions on the basis of whether or not it's false or true in our main program. So let's go about one by one here, and we're going to do this, of course, in the context of a small program, which allows someone to create a credit card and actually perform some of the functionality that we've outlined here. So in our credit card class, we actually have these comments, which will sort of guide us. These are of course the pseudocode to some extent, to some very trivial extent, they're pseudocode. So this is sort of the framework for our program here as a skeleton, if for the lack of a better word. And so for the first part here, we're creating instance variables. Now we know a class is but the definition, the template, or the outline for potential objects which could be instantiated in the future. And essentially for this one here, we start with our instance variables, but we more generally also have constructors and methods. So for our first part here, where we're just working with the instance variables, we're essentially going to have two variables. Or two instance variables rather. So we're going to have a private string, which is going to keep track of the name, and we're also going to have a private double, which is going to keep track of the balance. So these are, of course, instance variables. Now, a new set of instance variables is created each and every time an object is created. However, with that said, a static variable, let's say the credit limit, which I could equate to 500, and of course, I would have to actually specify the type of the instance variable that I'm actually using here. So these are instance variables, and this is a static variable. Now, for an instance variable or for instance variables, you must recognize that a new set of instance variables are created each and every time an object is created. What do I mean by that? What I mean by that is when you have a constructor, let's say public CC, and recall that the constructor name has to be the same name as the class. So when you have a constructor, you actually if you're not passing in anything to the parameters, usually what is done, we just use the default values, right? So in that sense, every time a new object is created, we have the opportunity to set, these instance variables are sort of set to default for that particular object, right? So if we were to go in our main method and we were going to say, okay, cc c1 equals new cc, and that's of course just C1 is of course just the object reference name, which would differ each and every time we create a new object reference. So this essentially sets off a trigger to whatever's inside this block of code. And since name and balance are essentially equating to the name and balance that we find on the class level here, each and every time we create a new object, we would just create a new, we would reference a constructor again, and that constructor would reference two instance variables on the class level and essentially give us the opportunity to actually change this to another name or another balance differing from object to object. So essentially, that's a notion that we understand with objects, and of course they're instance variables. However, with the static variable, we don't do credit limit is equal to 500 because it doesn't make any sense. The whole idea of a static variable is that it doesn't differ from object to object. The credit limit for each and every object we create will always be 500. So it doesn't make a lot of sense to use 500 or credit limit rather in a constructor, because we're not going to create a new set of credit limit each and every time an object is created. Name could differ, balance could differ, credit limit is going to stay the same. So it doesn't really, so we shouldn't go through the trouble of using credit limit in our constructor, knowing that credit limit will always be the same. So we don't need to create different instances of it each and every time we create an object. So now that we've sort of created this constructor, and of course I've used default values, but if I were to say string new name, in other words, if I had a parameterized constructor, then instead of setting name to default, I would actually have to do this dot name equals new name. And this is essentially saying that the name that you find on the class level is equal to the name that we find on the local level, the local variable called new name that we've created. Essentially what this says is that we have to distinguish between which name we're referring to. We can't actually just say new name is equal to name, because that would just set whatever we've created here equal to itself, which we don't want. So we say this dot name is equal to new name. In other words, the instance variable that we're describing is equal to the instance, or rather the local variable that the user has entered. And of course, whatever the user entered is going to be passed in through these parameters such that they may vet through this constructor. We're going to create some non-static methods here. The first non-static method we're going to create is setting the name. Now, when we set the name, it's going to be public because we want to be able to access this from outside the class. The return type is going to be void because we don't want to return anything. We're just going to set a name, and we're going to sort of leave the returning for the getter method. So this is the setter method, and so we say, okay, get name, and we're going to pass in a name, and of course this name is essentially going to represent what the user enters, and we're going to say that this dot name is equal to the name that we find on the local level. So again, the name that they will eventually enter is equal to the name that we find here. So this sort of ties in the name that they enter to the name of the object or the potential object. So this is the set name method. Of course, we're going to create the get name method. And for this one, it's going to be public as well, but instead of being void, we're going to actually return something. So we're going to say double. We're going to say set name, or we're going to say, okay, so this was a setter here, but we said get. So this is the set name. This is going to be get name. And get name is essentially not going to have anything in its parameters. It is instead just going to return name. So we would think that we would do the setter first and then the getter. In other words, after this dot name is equal to the name that they entered, we're going to return name, and that name would of course be the same name that they entered here. So it's not letting us return the name for some reason. So let's say we're doing public, we're specifying the return type, but the return type is double when actually we want to return a string. So we can't return a string if we're specifying double, and if we can't specify double and return a string, that doesn't make a lot of sense. That's our getter and that's our setter. So now we want to implement the ability to charge a card. If the price of the item being charged plus the balance is less than or equal to the credit limit, then add price to balance and return true. Otherwise, return false and leave balance unchanged. So there are two ways to do this. I'm going to describe way one. So we could, so we're going to have this, so this is going to be public, right? And since we're going to return a Boolean value, we're going to specify the return type as Boolean. This we're going to call charge, and charge is essentially going to, we're charging the card. So if we charge the card, in the event we charge the card, we're obviously charging the card on a particular amount, and that amount will essentially be passed in through the parameters here. So we're going to say double amount. So whenever we use the charge method, we're going to pass in an amount. And that amount will be passed in, and it says here if the price of the item being charged plus the balance. So let's see here. So if this is our condition here, right? So if the price, or if the, well, let's call this price instead of amount, just because items usually have a price, right? Although the price is an amount. But if the price plus the balance is greater than or equal to the, or let's say less than, right? Is less than or equal to the credit limit, because it has to be less than the credit limit, right? We can't be greater than the credit limit, otherwise we'd have exceeded our limit, in which case the transaction would more than likely be denied. So the price plus the balance is less than or equal to the credit limit. Now, so I think we've satisfied that Boolean constraint. So if the price of the item being charged plus the balance is less than or equal to credit limit, then we're going to do something. Now, when we say then we're going to do something, we actually open our block of code here. So we're going to say, and then add the price to balance and return true. So it's saying, well, we're going to update balance. The balance variable is going to be balance, or it's going to be balance plus price. Okay, and we're going to return true. Else, return false. That seems that seems like, I mean, it seems like that's what we should do, right, on first glance. If the price of the item being charged plus balance is less than or equal to credit limit, then add price to balance and return true. Add price and then return true, otherwise return false and leave balance unchanged, in which case we're not actually doing anything to balance in this particular block of code, so we assume that balance is left unchanged. There are really two things that I want to talk about here. If we're using something like price plus balance, we're actually taking two variables and adding them up. That's completely fine, but it would be better to actually store that in a new variable itself. So we could say double price plus, or we could say new balance is equal to price plus balance. And knowing that new balance stores price plus balance, we can just reference new balance here. And that would make our code a little more understandable, right? So this is one thing, right? This is one thing. The other thing is here, we're just blatantly returning true or false. That's fine. But of course, in our main method, we want to be able to say, look, if we want to be able to store the result of this in a variable, and basically we want to be able to reference something. This returns true or false, but it doesn't return a variable which we can reference. Just to make this more clear here, let's just say Boolean true, or actually let's just say Boolean accepted, which signifies whether or not the charge was accepted, equals false. So it's going to be false to begin with. However, if the new balance is greater than or equal to the credit limit, then we're just going to say that the that accepted is equal to true, right? Because it satisfied our condition, and the charge is only accepted when this condition is met, and so accepted is true. Otherwise, accepted is equal to false. Now, the thing with this is that we actually don't have to specify else accepted is equal to false, because that is implied. So if it's not, so if new balance is not greater than or equal to the credit limit, then balance is never updated and accepted is never set to true. By default, it is set to false. And so what we can do in this case, instead of sort of explicitly saying else and then having a code block, we could just say return accepted. Because if this is triggered, if this block of code is triggered, then balance will be updated and accepted will be true. And then when we return accepted, it will hold the value of true, not false. But if it doesn't go inside this block, it will of course return the value of false. Now there's going to be another variable, or another method, which is of course, it's of course non-static. It's going to be a public Boolean, and it's going to be called pay. So this is going to be paying off a particular amount. So let's just say double amount. Whenever we want to use this method, we're going to pass in an amount, which of course is going to represent what the user will eventually enter. For this one here, when we say double amount, for this one, so there are really two things, right? So we don't want to pay a negative amount. So if the amount is greater than 0 and the amount is less than or equal to the balance, subtract price from balance and update balance instance variable and return true, else return false. So let's have, again, another Boolean variable which keeps track of whether or not the transaction goes through or not. Now, if the amount that was passed is greater than 0, then we know that then this catches our attention, because again, we don't want to pay a negative amount. That just doesn't make sense. So if the amount is greater than 0 and the amount is essentially, it should be of course less than or equal to the balance that we have in our amount or in our account, right? So if it's greater than the balance, then of course we can't pay it. But if it's less than or just equal to the balance, then it seems like we can pay it, right? And of course, this balance is referring to the instance variable. This is referring to the local variable, and this too is a local variable. It's not the same variable that we find in this method, because of course, any method created, even if it shares the same name in a particular method, it only exists within its closest braces within which it is confined. So if amount is greater than or equal to 0 and amount is less than or equal to balance, we're essentially going to say balance is equal to the balance minus the amount, because of course we want to subtract off the amount so look, this particular block of code signifies that the charge can go through. because this condition says, well, the amount is greater than 0, which means we know that the item actually holds an amount, and the amount is less than or equal to the balance, in which case we actually can afford it. So this just says that yes, it's a price, which makes sense, and this just says that we can actually afford it. So this code is going to say, well, if you can afford it, then take whatever balance you had and subtract off the amount, because you're no longer going to have that amount anymore once you pay for the product. And so we're just going to say that the Boolean accepted is equal to true, right? And we're not, again, we could say else, Boolean accepted is equal to false, and leave balance equal to balance, right? But we don't have to really do those things, because we know if this is not the case, then we're returning false, which is what we wanted, right? We're returning accepted, which would be false. If it were true, then we know that this was set off. So now we're going to create a setter, which is going to be a static method for all credit cards, where we can increase the credit limit. So essentially, it's going to be, so this is going to be increase credit limit. And it's going to be a static variable. So we have a static method for a static variable. So for this one here, it's going to essentially be public. And we're going to say set, we're just going to call it set credit increase. And it's going to be void because it's not going to return anything. And we're going to pass in an amount, which is going to be called the new credit limit, right? Now, it doesn't make sense to have a method which increases the credit limit and then give the ability to the user to actually enter a credit limit which is less than the credit limit that we have now. So we're just going to say, look, we have a static variable called credit limit, which is 500. Okay, and so if the credit limit that we're referring to on the class level, or rather if the new credit limit that we just created, which the user would enter in eventually, is greater than the credit limit that we have on the class level, then and only then would it really make sense to actually set the credit limit that we had before equal to the new credit limit. Okay. Otherwise, it just doesn't make sense at all. In which case, it's not going to do anything, right? And so we don't have to really specify that else, because it's just not going to do anything, right? It's just going to leave the credit as the same. It's not going to make any changes. So that's really setting the credit limit there. And getting the credit limit would, of course, be another public method, which is going to be essentially it's going to return a double, right? Get credit limit. We could just say credit limit. And we're going to just return credit limit. Now, if we increase the credit limit, then we would actually, then the credit limit would be set to something else. And then when we return credit limit, it would be whatever they set it to. But if we don't set the credit limit to anything, it's just going to sort of return 500. Now we're going to set the balance. So this is going to be a public method. It's not going to return anything because setters are void. And we're going to call this set balance. We're going to pass in a double, which is going to represent the balance. And we're going to essentially say that this dot balance, which is on the class level, is going to be equal to the balance that we've created on the local level. Getting the balance is, of course, making another method, which is going to be public. And we're going to return a double. And because, of course, the balance is a double. And we're going to call this get balance. We're not passing in anything into the parameters because we don't want to make any changes. We just want to return balance whether or not changes were made. So this is our class definition. Now we're in Scratch. We have a do while loop, which essentially says that until the option does not equal to 7, don't end the program. So for this one here, if the option, and of course we could use a switch statement, but I'm just going to say if statement. So if the option is essentially equal to 1, then we're going to change the name of the card holder. What that involves is we're going to print out a print line statement which says enter name, right? And then of course we have to make it possible for the user to actually enter a name. we're going to use next to actually enter in a single line. Once they've entered that name, we're going to refer to a object reference that we've created. And we're going to do dot, and we are essentially just going to say, we're going to say set name. And we're going to pass in whatever they entered here, and that would update the name. Now, we don't actually have an object reference, so we create an object reference. So we're going to say, okay, CC, which is, of course, referring to the class from which the object reference will be derived. We're going to call this C1 equals new CC. This is, of course, referring to the constructor, which I don't think is default. Let's just make this constructor default. We're just going to set name equal to something. Now this works. So our object reference is actually called C1. So this updates the name. Otherwise, if the option is equal to 2 and not 1, then we're going to charge something on the card. This is where we use our charge Boolean method. So this is, of course, referring to our Boolean method, right? So if they charge something on the card, we're going to ask them how much, or let's just say enter charge amount. And for this one, of course, we're going to make it available to the user to actually enter the amount so that the program waits for the enter or whatever the user enters. So we're going to say amount, or let's just say price, equals data.next double, because the price will be a double. And if it's not, that's completely fine because double is compatible with integer. And for this one here, we're essentially going to, say, look, whatever they, so we're going to create a Boolean. We're going to create a Boolean. And we're going to essentially say the Boolean is accepted, if the charge was accepted or not. That's the idea of using the variable name called accepted. So accepted, so this Boolean can either be false or it could be true. But recall that if we refer to the charge method, which takes in a price, or C1, takes in a price, we know that this method either returns false or true. Because if you go here, our charge method returns either false or true, whether or not the transaction went through. So we're going to run whatever they enter into a particular method, which is going to be responsible for charging the price. And if the price is charged, then balance is updated to represent the fact that you either that your balance is updated to represent a deduction, or actually an addition. And in the case of pay, it would be a deduction. So we could say here that if accepted is true, we could say either if accepted is true, then if accepted is true, we can say payment or charge or payment accepted. Right? Otherwise, we can say payment denied. Okay, and this is, of course, for the option 2. Now, this is, of course, a longhand at saying whether or not a Boolean variable is true or not. In this case, we could just say accepted. The variables themselves return true or false. So Boolean variables, that is. So saying this here would be true, and this one would be false. So if we wanted to say if accepted is false, do something, we could do that, or we could just do this, which is, of course, saying that it's true. Otherwise, if option is equal to 3, in this case, what do they want to do? It seems like they want to make a payment on the card. It would essentially be the same process. So just to save time here, let's just say same process. Okay. Or actually, let's just go through it. So if option is equal to 3, we're going to make a payment on the card. We're essentially going to ask them to system.out.print enter amount. And we're going to say, well, we're going to give them the option to enter an amount. And after they do that, we're going to refer to the object that we have, or we're going to make a Boolean variable, right? Which is going to be called accepted. Again, we're just doing the same thing for the charge, right? Accepted, and we're going to say we're going to refer to the object reference, and we're going to pass in pay, and that is going to take in an amount. And I think we're just going to be doing the same thing that we did here. So let's just copy paste. Ooh, rough. Yeah, so that I think now we're in our class. We're not actually in. So yeah, so that seems like we were sort of in another program here. Let's take out system class. So this is for the payment. This is for the charge here, and that works. That works awesome. So we essentially did the same thing, which is actually why I didn't want to do this, but I guess for purposes we could. So we press 4 to look at the balance on the card. So if this is for option 3, so else if option 4, we're essentially going to look at the option on the card. Or we're going to look for the balance on the card, balance. And we're going to refer to the object, and we're going to do get balance. Okay. Otherwise, if option is equal to 5, we're essentially going to look at the credit limit. Okay, so this would be system.out.println. I'm going to say that the credit limit is this. We're going to say get credit limit. Now, of course, this doesn't work because we're not referencing the object. Reference. Also, if the option is equal to 6, we're essentially going to increase the credit limit. Awesome. So we're going to say enter amount of increase. And we'll say they can enter double, right? Double increase equals data.next double. And they can now essentially we can now reference the object and then do, let's see what we have. Set credit increase. So we're actually going to be entering increase, which is what they enter. And that would set the new credit, right? Press 5 to look at the credit. Press 6 to increase the credit, and press 7 to end the program. So else if option equals 7, we're essentially just going to do system.out.println, and we're going to print out goodbye. And that's it. Now, if they enter anything else, we'll just say invalid. Invalid choice. Invalid choice. And this I'm going to do ERR, which is sort of going to mean that it's going to show me this print statement in red. I actually want to do that for all these print statements that I have that are asking me to enter in the amount and whatnot, because it allows me to distinguish from the options and the declarations of the program, sort of. Let's see, do I want to do this? Yeah. Seems like a lot more work than I anticipated. Okay, so hopefully this works, right? Let's run our program. Let's press 1 to change the name of the card holder. So I guess I could do that. I could enter the name here. Let's say David. And now, I guess I wanted to have something which I could actually look at the name, right? Let's see. Let's do something fancy here. Actually, let's just say enter. Geez, this is problematic, right? Enter 7. Look at name. So I have to go back to 7. And you know what? I actually don't want to do this. Let's just not look at the name. Or we could just say enter 8. Look at name. And we can say else if the option is equal to 8, then it would essentially display the get name method, which would return back the name. But of course, this must be before the final else. Good, that should probably do it. Now we'll look at the name and see if it updated. Yes, it did. So now let's see if we want to make a payment on the card, right? So we're going to enter in 3, and we're going to enter an amount. So let's just do this again here. Right now, if I look at essentially if I look at my balance, I have nothing. My balance is 0. But if I make a payment, or if I make a charge rather, and I say 400, right? The payment is accepted, right? But if I make a, so I'm actually drawing on the credit limit here. But you'll see that if I enter a charge amount of 900, that sort of represents something that is beyond my credit limit. So if my credit limit was 1,000, then I could draw 900, but I can't draw 900 right now because my credit limit is 500. So let me actually go ahead and change my credit limit. Let's see if I can increase my credit limit. So I say enter the amount of increase. 6 essentially signifies to increase the credit limit. So I'm going to enter the amount of increase. I'm going to say, let's say 1,000, right? So actually, let me say 500 because currently it's 500. So if I do 500 more, I should have a credit limit of 1,000, which should let me draw the 900 that I wanted to. Okay. Yeah. So I don't think my method essentially allows me to add on to the credit limit that I had before. I think that would be a separate constraint. I think what it does is it just let me view my credit limit. 5 to look at the credit limit. It's 500. So I can't actually add on to it. I can declare a new credit limit. I can say increase the credit limit. So I could say I could increase the credit limit to 1,000, right? But I can't add 500 onto it. So now if I want to charge 900, it would make sense and the payment would be accepted, whereas before it was denied. And that works. And of course, if I were to, let's see, look at the balance, it's sort of added 900 to my account. And now I can essentially make a payment for anything below 900. I could do 600 and the payment would be accepted. But that would leave me with 300 in my account, right? So my balance would now be 4, so it leaves me with 300 in my account. But of course, if I wanted to buy something, if I wanted to pay something, so if I wanted to make a payment of 400, my payment would be denied. But if that same payment was 200, my payment would be accepted. And of course, I get to look at my name. It seems like for this run, I haven't actually initialized a name. So why don't I actually enter a name? and then I can look at the name. But so essentially the idea of encapsulation and the idea of creating these methods in a class and stuff, it allows me to make changes if I want to. So you'll notice that if I want to actually increase sort of my credit limit, I set that if I wanted to increase my credit limit, let's see, at 3, if I wanted to do the number 6, that would allow me to increase my credit limit. But this sort of implies that it's saying enter the amount of increase. So right now I have 1,000. If I do 500, it should increase it by 500. So I should have 1,500 as the credit limit. But when I look at my credit limit now, it says the credit limit is 1,000. So it really hasn't added that 500 onto, where has it? Let's see here. So essentially what I do is so 5 to look at my credit limit, it's 500 right now. And if I increase the credit limit and I say 600, and then I look at the credit limit now, it's just 600. So it didn't add 600 with 500. It just, so whatever I entered here, the amount of increase that I wanted, it just entered here. So what I should go back into my set credit increase. And instead of saying set this to this, what I could do is I could just say, what I'd want to do is I would want to establish the class credit limit as adding the credit limit specified, the new credit limit specified. So in that case, I could just say that the credit limit, and this is of course referring to what I have on the class level, can be the credit limit plus the new credit limit. So now I can just specify in a particular amount, and it's going to change that credit limit to something. So now when I have this here, I can say 5 to look at my credit limit right now. By default, of course, it's 500. But when I specify a new amount and I say press 5 to look at when I say press 6 to increase the credit limit, and I specify a new amount and I say 500, now my credit limit should be updated to 1,000. So if I look at my credit limit now, it says 1,000. Whereas before, if I were to specify any amount, it would just set it to that amount. So that's why it's so convenient to work with programs in an object-oriented fashion, because if I want to do anything with the credit limit, I know where I need to go and which segment I need to sort of consult in that regard, right? So that is really the idea of this video. Thank you.